Uh, just wanted to let you guys know. We saw the food was ready, so we'll make this quick. So I'd like to start by saying thank you for having us here. It's an honor for two guys like us to be between the caliber of people like you guys. It's an honor for us. And I'd like to start by saying, Genius let me just wait for the slideshow, actually. Oh, yeah. Why robotics? I know it's a question we get asked a lot. Why do we use robotics to teach students? We believe in solving modern problems with modern solutions, and that is through teaching the youth how to use their minds to come up with new and modern innovative ideas. So one of the main things we're faced with is the 14 engineering grand challenges. There is pollution, carbon pollution, water pollution, world hunger. And how can we solve that? We can solve that by teaching young minds to think innovatively and placing them in a simulated environment based on a theme. So I believe we have a video next up. Let's just see. Oh, okay, not yet. Okay, so the challenge. So let me tell you guys about the first global challenge. So every year, 5 students from 197 countries participate in a selected venue. This year it's going to be in Athens, Greece. We've been in 7 different countries. Just to mention a few: Dubai, Singapore, we've been in Switzerland, we've been in Washington, we've been in Mexico, and there we had the privilege to both mentor and participate in all these competitions. I would like to mention that in 2022, we ranked 7th in the world. Yeah. So these challenges focus on sustainability, as I said many times, teaching the youth to think innovatively and placing them in a simulated environment. So the video that's going to display is just going to show you guys the theme for this year. Okay.
Every day, each of us is faced with the same question: what am I going to eat? Food is our fuel, our culture, and our comfort. Yet in a world of abundance, more than 700 million people are going hungry. Our global food system, which encompasses producing, processing, distributing, and consuming food, is a complex and interconnected web that is sensitive to many factors. It is straining under the effects of inefficiencies, changing consumption patterns, conflicts, economic shocks, urbanization, and environmental degradation, and the rising cost and scarcity of food is impacting everyone. In many ways, our world produces enough food, but inefficient production and consumption causes 30% of all food to be wasted. Resource-intensive meat demand is skyrocketing, and conflicts are blocking food from millions. Agriculture is the largest consumer of fresh water, while food production and delivery consume approximately 30% of the world's energy. So as our global population continues to increase, so will the demand for food, water, and energy. To develop a more sustainable food system, we must achieve economic sustainability by establishing a fair and profitable system from farmer to consumer. Social sustainability by securing the well-being of all societies and their equitable access to nutritious food. And environmental sustainability by balancing between food, nature, and climate to neutralize our ecological footprint on the planet, minimize wastage, and advance methods that are less water and energy dependent. From regenerative farming and landless agriculture to small-scale automation and optimizing plant-based options, innovative solutions are continuing to emerge. Together, we can nurture a more resilient and equitable food system that meets the needs of the present and generations to come. Join us for the 2024 First Global Challenge, Feeding the Future.
Okay. So some of you guys might be wondering, so how do you implement skills and how do you go about tackling these challenges? So how we do that is by placing students, as I said, in a virtual and simulated environment where they not only have to work together, but compete with basically each country in the world, where each student is placed with 2 other teams. They don't even speak the same language. So you have to cross communication borders and somehow tell that guy, okay, don't drive there, don't go there, don't go there, which is a challenge, but many students form a very special kind of bond where normally you never see such a thing. And most students actually come back very different, either inspired to do engineering, computer science, or most of them want to change the world. So the next video is going to be a demo of what one of these simulated environments look like. So this was for 2023.
2023 first global challenge, Hydrogen Horizons. In this game, 2 3-team regional alliances work independently to produce, store, transport, and convert hydrogen into other useful forms of energy before coming together as a global alliance to demonstrate each nation's proficiency in hydrogen technologies. Robots start the match lined up against the guardrail next to their corresponding alliance station. 144 green hydrogen atoms and 72 blue oxygen atoms are randomly pre-positioned in the central reservoir in the form of water, or H2O. The match begins when the announcer says, "Go!" For the first 2 minutes of the match, each regional alliance works to extract water from the reservoir, and then use energy to break the bonds that hold the hydrogen and oxygen atoms together. Robots can perform the separation, or teams can use the electrolyzers to sort the atoms by size. Robots proceed to store hydrogen, an energy carrier, in the mobile hydrogen tanks, and oxygen in the corner oxygen accumulators. Human players can assist with storing oxygen only. If an oxygen atom accidentally enters the hydrogen tank, human players may remove the stray atom. When each regional alliance decides their hydrogen tank is filled, they transport the hydrogen tank to align it under the oxygen accumulator. Once the hydrogen has been transported, the energy it carries can be converted into a different usable form. At any time during the last 30 seconds of the match, a regional alliance can press a button to initiate the conversion process, releasing the oxygen so that it may fall into the hydrogen tank to earn a conversion multiplier. This is applied to the total sum of hydrogen and oxygen atoms in the hydrogen tank at the end of the match. Partial alignment represents the combustion of hydrogen to produce heat, which has reduced efficiency due to combustion heat losses. Full alignment represents the combination of hydrogen and oxygen in a fuel cell to produce electricity, which is the most efficient method of conversion. During the final 30 seconds of the match, the regional alliances combine into a single global alliance to position their robots on the hydrogen hub, demonstrating each nation's technical ability to use hydrogen as an energy carrier. A robot fully supported by the reservoir boundary, or the playing field surface within the reservoir boundary, demonstrates intermediate proficiency, while a robot fully supported by the hydrogen hub structure demonstrates expert proficiency. All teams on the Global Alliance earn the total sum of all robots positioned on the hydrogen hub. The Global Alliance earns a cooperation bonus if 5 or more robots are fully supported by the hydrogen hub structure at the end of the match, celebrating the mutual benefit when the majority of nations are proficient in hydrogen technologies. The final score is the sum of hydrogen and oxygen points, multiplied by the conversion multiplier, plus proficiency points and cooperation bonus points. The regional alliance with the highest score wins the match.
Okay, so we can just go to the next slide. Yeah, through participation in First Global and Genius Robotics, every student has an opportunity to transcend nations in athleticism. So I'm just going to skip through due to time. By engaging in these challenges presented by these programs, students not only develop technical skills, but also embody the spirit of competition and collaboration. Okay, we can skip. So I'll just skip this video so we can go on. Yeah, so our impact that we've had in Namibia, us as First Global, we've trained over 100 students. We've handed out more than 40 kits, robotics kits. We've attended 7 international challenges. We've raised over 300,000 annually, which we then use for non-profit activities. And yeah, we've ranked 7th globally in 2022. So we'll skip this as well. And then a recap of First Global. So just to show you guys as a testament of we were there, this is just a short video of Team Namibia participating in 2022. Okay.
Earlier, and right now it doesn't look like they're going to be able to get more components than that makes the first global challenge unique. We're going to start this game up in 5, 4,
Team
3,
Israel has a
2,
two-hook component to their
Let's go.
hanger. They're slightly hanging off, but I'm going to leave it up to the judges and the referees on the field to make a call of that mentality.
Yeah,
Because
we've got our
all
own pressures
6
up here.
robots
Thankfully, that is
on
not
the
one of
field
them.
are
They're
working
the
together
experts,
to
and they're on the
carbon
field
sink and
with
fight
the
the climate
students,
change
talking
we're
it
seeing
out,
on our field right
ensuring
now.
that
On our Red
everything
Alliance,
is
we have
up to
Nepal,
code, but either
Kazakhstan,
way,
and
we got
Costa Rica
smiles on the field, and
versus
that's
the
all we
Blue
really care
Alliance,
about at the end of the
Marshall
day. We
Islands,
want to make sure our
Japan,
teams are
and
having a good
Namibia.
time.
But
as they
honestly, up
fight,
until the
they
last
face
30 seconds of this match,
incredible
challenges
all
such
6
as
teams
this game this
are
year
one alliance together, which
So
is,
that
I think,
was the
brilliant.
final match. Now, Japan, we just focused on them. They are actually formed by 3 players coming after just about every one of these matches, each looking different than the other. We've seen, I think, 3 ties today. Some experience in other parts of first as they make their way into first. We'll see what happens. Again, a very independent experience that we've got here. At the end of that game, will wave their hands at the bottom. That's going to indicate everybody waits with bated breath. Central
Something that I
carbon
think is
sink.
really important
As
that
every
teams are definitely
centimeter
talking about tonight
climbs
as they go
in
home,
that
have
center
their
sink,
strategy
that's
meetings
what's going to
Okay, I
indicate
think
those
we can
points at the
end
very
it
bottom.
there.
That's why they're currently even. But
So
end
that
game
brings
in
up
that
the
last
question.
30 is when these
Taking
teams
a
start
look
separating themselves.
at
So when Saul
The
approached
end
us with the opportunity to
that
not
math
only
really
Take a look at the
commercialize
play.
but build on our business skills, we of course had to say yes. And through our partnership, we've been working on Zolt for some time. This is phase 1 of our prototype. We've had some disasters, but also some successes, and we're looking to not only commercialize it, but see how advanced we can make it. Thank you.